Alright, in this video we're going to be looking at the measures of center, and what we'll be doing is finding the mean, the median, and the mode and the mid-range of a set of data, which is just the basis of this particular section. Alright, so let's define what a measure of center is. Okay, a measure of center is this. It is a value at the center or in the middle of a data set. Okay. A measure of center is just a value at the center or the middle of a data set. And there are several different ways that we can determine the center. Okay, so we do have 4 different measures of center. That is the mean, the median, the mode, and the mid-range. Okay, so in this case here, we'll start off with the mean. And sometimes they call it the arithmetic mean. Okay, and that's basically finding the average of a set of data. In other words, what you're going to do here is you're going to take all your individual data values, add them together, and divide by how many data values that you have. Okay, now we do have this formula for finding the mean. Okay, and it's this formula here. Now this Greek letter sigma means find the sum of all your x values. So here this represents the sum of all data values. And your n represents the number of data values that you have. Okay, so in this case here, you just take the sum of all of your data values and you'll divide that by the number of data values that you have in that set of data. Okay, so in this particular case, now, when we're dealing with a sample, which is going to be a subset of a population, and the population, by the way, is going to be the entire set of values that you're going to be dealing with. That's the entire group. Now, for a sample mean, we use x with a bar on top, meaning sample mean. Okay, and that's of course the sum of all your x's divided by lowercase n. And lowercase n represents your sample size. X represents each individual data value. Okay. Now for the population mean, instead of using x bar, we use the Greek letter mu. Okay. That symbol right there represents the Greek letter mu, and that's going to be equal to the sum of all your x values divided by capital N. And capital N represents the size of the entire population. Okay, so we do have a sample mean and we do have a population mean. Mainly in this class what we'll be using is just a sample mean, but do be familiar with this Greek letter mu, which is your population mean, because you'll be seeing that again later on in other sections. Okay, now the second measure of central tendency is the median. Now the median, by definition, is the middle value of a data set when it is arranged in order of increasing, or it could be decreasing, magnitude. In other words, pretty much to find the median, you have to put the data set in numerical order, preferably from least to greatest. And that middle number is always going to be the median of that set of data. Now, there are some conditions of finding the median of a set of data. Okay, and that's this. If there is an odd number of data values, that means if there are 5, 7, 9, 13, etc., those are odd number of data values, then the median is the middle number. Okay? An odd number of data values means you can easily find the median by just locating that middle number. Now, if there's an even number of data values, if there is an even number of data values in a set of data, like let's say 6, 8, 10, 20, etc., then to find that median, you have to take the average of the two middle numbers. Okay, so for the median, if you have an even number of data values, then to find that median, you have to take the average of the two middle numbers. Okay, and I do have some examples or illustrations of just this. Now, if you look at the one on the left side, you have a median when you have an odd number of data values on the left side. In this case, we got 5.40, 1.10, 0.42, and then 0.73, 0.48, and then 1.10, and 0.66. Now, what I'm going to do here is put these in numerical order. So in this case here, in numerical order, this will be 0.42, 0.48, 0.66, 0.73, 1.10, another 1.10, and 5.40. Okay, so that's the data set in numerical order. Now, if we find the middle number, probably the easy way to do this is cross out the first and the last numbers in that set of data, and then continue to do that until you get to the middle number, which is in this case 0.73. So the median of that set of data will be 0.73. Okay, now let's suppose we have something like this. Let's say 0.42. And this is going to be sorted. 0.48, 0.73, 1.10, 1.10 again, and 5.40. And this time we want to find the median of this set of data. Now this time there are 6 data values. So in this case, if I cross out the first and the last numbers in this set of data, you'll see that I have two middle numbers, 0.73 and 1.10. So now in this case, I will have to add these two numbers together and divide by 2. So 0.73 plus 1.10, divide that by 2, that will give you 1.83, and divide that by 2, you'll get 0.915. So the median of this set of data is the average of the two middle numbers, which is in this case 0.915. Okay, so that's how you find the median of a set of data. Okay, now the third type of central tendency, or the third measure of central tendency, is called the mode. Okay, the mode is going to be the data value that occurs with the greatest frequency. Okay, it's the data value that occurs with the greatest frequency. Now, a data set can have one mode, more than one mode, or no mode. Okay, so let's look at some examples of just this. Let's say I have this data set 5.40, 1.10, 0.42, 0.73, 0.48, and 1.10. Okay? In this case here, by looking at this, I can find the mode, which is in this case 1.10. This one only has one mode, because that's the data value that occurs the most frequent. Now suppose I had this set of data, 27, 27, 27, then 55, 55, 55, 88, 88, and 99. And here I want to find the mode of this set of data. In this particular situation here, notice I got 27 appearing 3 times. Also, I have 55 appearing 3 times. So here I got 2 modes, 27 and 55. Now this is what we call bimodal, because it has 2 modes. Now if there's more than 2 modes in this set of data, we can call that multimodal. Okay? Now suppose I had this. Let's say 1, 2, 3, 6, 7, 8, 9, and 10. And I wanted to find the mode of this set of data. Notice that this set of each data value occurs only one time. Here, no data values are repeated. So that means this set of data has no mode, because each number occurs only once. There's no repetition in any of those data values. So we consider that set of data to have no mode. And the fourth measure of central tendency, mid-range. In this case, that's going to be the value the mid-range is the value midway between the maximum and minimum values of a data set. And in other words, what you're going to be doing here, you're going to take the maximum value and the minimum value, you're going to add those together and divide by 2. So when you find the mid-range, I'm just going to say the minimum plus the maximum, and I'm talking about data values here in this case. That sum is going to be divided by 2. Okay. So basically, that's what you'll be doing in this particular video. We'll be finding just those 4 measures of center: the mean, median, mode, and mid-range. Okay, so now let's look at some examples of just this. Alright, listed below are the head injury measurements from small cars that were tested in crashes. The measurements are in HIC, which is a measurement of a standard head injury criterion. The lower HIC values correspond to safer cars. The listed values correspond to cars A, B, C, D, E, F, G, and G, respectively. Here you're going to find the mean, the median, mid-range, and the mode for the set of data. And then you'll also complete parts E and F, which is this: which cars appear to be the safest, and based on these limited results, do the cars appear to have about the same risk of head injury in a crash? Okay, so let's start off with part A, finding the mean of this set of data. Now, before I do that, what I would do is go ahead and put this set of data in numerical order. So here, I'll start off with 304, and then 341, and then 358, and then 386, 492, 514, 536. In this case here, you see that this set of data is not sorted. So first of all, what I'm doing here is putting those data values in numerical order from least to greatest. Okay, so now let's go ahead and find the mean of this set of data. The mean, of course, will be x bar, and that's going to be equal to the summation of all your x's divided by n. So that means we're going to take the sum of each of these individual data values and divide that by, in this case, 7, because there's 7 data values here. So if I add 304 to 341 to 358 to 386 to 492, 514, and 536, I would get 2,931 and divide that by 7. So 2,931 divided by 7. Now to one decimal place will be 418.7. Okay? And keep in mind, on the homework, they're going to ask you to round to a certain number of decimal places. So make sure that you follow those instructions and round to, in this case, 1 decimal place for the mean, and also for the median, and also for the mid-range. Okay. Now the mode, you'll leave the value as is. Part B is the median of this set of data. Now the median is the middle number of this sorted data. Now notice I've already put the data values in numerical order, so you know that way you can find the median easily. Here there are 7 data values, so the middle number of this sorted data set is your median. And here the middle number in this case is 386. So the median of this set of data would simply be 386. Okay. Now part C is the mid-range. Now anytime you're finding the mid-range, you're going to take the minimum data value, which is 304, and you're going to add to it the maximum data value of 536. So you have 304 plus 536. The sum is going to be divided by 2. So if you add 304 to the 536, you're going to get 840. And 840 divided by 2 would be 420. So the mid-range of that set of data would be 420. And then part D is finding the mode. The mode is the data value that occurs the most frequent in that set of data. In this case here, none of these data values repeat, so we can say that this set of data has no mode. Okay. Now part E, which car appears to be the safest? Now, according to the directions, it says here that if you have a lower HIC value, that corresponds to the safer cars. The lowest HIC value that I see here is 304. Now, going back to this original data set that's in this particular order, we see that 304 corresponds to car G. So car G has the lowest HIC value. So we can say that car G is the safest. Okay. All right, and then finally part F, based on these limited results, do the small cars appear to have the same risk of head injury in a crash? And in this case here, the answer there will be no. Because if you look at those data values, they differ substantially. You have a low value of 304 and then the high value of 536. There is a big gap in between those two data values. So no, it would not be, those small cars do not appear to have the same risk. Okay, so that's how you find the mean, median, and the mode and the mid-range of a set of data. Okay, now let's look at another one that has additional data values here. Now these data values here are the playing times in seconds of songs that were popular at the time of this writing. Here you want to find just the mean, median, mode, and mid-range for a given sample data. Is there one time that is very different from the others? Okay, so these are the data values that they give you originally. But first of all, we would need to put these in numerical order from least to greatest. So let's start off with the smallest number, which is 216, which occurs twice. And then 224. Then 231. And then 239. 241. Then 244. Then 247. Then 252. Then 255, 257, 259, 283, 291, and 446. Okay, and I'll make that 283 look like it's 283. Okay, so now our data values are sorted from least to greatest. Now we can find our mean, which is of course x bar equaling to the summation of all your x's divided by n. Now if you take the sum of all your x's, if you take the time to add up all these data values together individually, you should get a sum of 4,148. And there are 16 data values, so you'll divide 4,148 by 16. Now, rounded to one decimal place, you're going to get 259.3. So the mean of that set of data would be 259.3. Now for the median of this set of data. The median is going to be the average of the, well, actually there's 16 data values, so that tells me I'm going to have two middle numbers. So the median is going to be the average of the two middle numbers. So let's say you were to cross out the first and the last and keep doing that until you get to the middle. And actually, I'm missing another number. That's 247. Okay. So that 252 were gone. Notice you have two numbers in the middle, which is 247. Okay. So if you take the average of those two, it'll end up being 247. So the median of that set of data would simply be 247. And then part C is finding the mode of that set of data. The mode is the data value that occurs the most frequent in this set of data. Notice that 216 occurs twice, and also 247 occurs twice. So now we have a set of data that is bimodal. We have two modes, 216 and 247. And then the mid-range. Now the mid-range is taking the minimum data value, which is 216, plus the maximum data value, which is 446, and divide by 2. So if you add 216 and 446, you're going to get 662. 662 divided by 2 would be 331. So for this data set, the mid-range is 331. Okay. Now, is there one time that is very different from the others? Well, if you look at the set of data, you're going to see that 446 is far away from the other data values in this set. So, to answer that question, it would be that yes, and the time 446 is very different from the others. Okay. Okay. Now there is a name for that when the data value is far away from the other values in that set of data. They're called outliers. Later on we'll talk about what outliers are. Okay. Alright, let me do one more example. And that's this one. Statistics are sometimes used to compare or identify authors of different works. The first 10 words in a book by Terry are listed with the first 10 words in a book by David. Here you want to find the mean and the median for each of the two samples and then compare the two sets of results. Okay? So in this case here, I'm going to start off with the set of data for Terry. And I'm going to put these in numerical order. So here I'm going to have, let's say, 1, 2, and then 2, then 3, 3, 3, 3, 4, 6, and 10. Now we're only finding the mean and the median of this set of data. So for the mean, that's your x bar, which is equal to the summation of x divided by n. So here we take each of these data values, add them together. You should get 37. And there are 10 data values, so 37 divided by 10, that's 3.7. So that average is going to be 3.7. Now for the median, there are 10 data values, so we look for the two middle numbers here. If I was to cross these out, obviously the two middle numbers will be 3. Now if I go ahead and take the average of those two middle numbers, that would be 3. So the median of this set of data would be 3. Okay, now next I'll look at David's mean and median for the number of words in his book, in his books. So here's David. And for the mean, of course, that's x bar equaling to the summation of x divided by n. Now before I find the mean, let me sort his data values in order. So we have 1 and a 1, 2, and we got 5 3s, and 2 4s. So that's his sorted data. Okay? That's the length of the first 10 words in his books, in a book by David. Now, add these numbers up, you'll get 27. There are 10 data values, so 27 divided by 10 would be 2.7. So the mean there would be 2.7. Now for the mode, the median. We just want the mean and the median of this set of data. What we'll do here is find the two middle numbers because there are 10 data values. We have an even set of data. Notice that the two middle numbers are 3, so if I take the average of those two middle numbers, that's also going to be 3. So the mean is going to be 2.7 for David, and his median would be 3. So if I was to compare these, based on the results, that the number of words in Terry's books are longer than the words in David's books. So I can conclude here that Terry's words in his book are longer than the words in David's book. And the reason why I say that, because the average in Terry's books is bigger than the average in David's books. Okay, so that's how we can compare these two results here. Okay, and that will conclude this particular section on finding the measures of center.